All right, hello class. Today we're going to talk about combinations. So they are very similar to permutations. So remember, permutations are when order matters. Combinations is whenever order doesn't matter. So the key thing to remember here is that order does not matter. So for combinations, order does not matter. So like, let's say you're playing poker. You draw out 5 cards in your hand. It doesn't matter what order you get those cards in your hand, they're just in your hand. So these are the things you want to think about whenever you're doing these. Does order matter? Does order not matter? So if order does not matter, it's a combination. If order does matter, it's a permutation. So combinations just are elements. We're going to represent it very similar to what the permutation did. So there's going to be n objects, and we're choosing r at a time. You just got to specify this combination. So it's a combination of n things taken r at a time, or n things chosen r at a time. So let's say we're going to take the letters A, B, C, D, and we want to figure out how many words we can make by using them using permutations. So permutations, remember, the order matters. So ABC, ACB, BAC, CAB, BCA, CBA. Those are all different words, technically, in quotation marks. And then same thing here. All of these are just different ways to rearrange those 3 letters. Same thing here, same thing here. So if I were to count all of these, we would have 24 combinations, and that would be a permutation of 4. Choose 3. But in a combination, order doesn't matter. So if I wanted to count the number of ways I could choose 3 letters from those 4, then what would happen is basically this whole row, or column, I guess is more like it, would just be reduced into these letters. So it doesn't matter if I have ABC or ACB, I just have those letters. So that would be just a combination. So combination should always be a smaller number because order doesn't matter. And we're kind of just dividing out the number of ways I can rearrange those. So the way that this looks, and then like if you think about this column, these are just all the ways I can rearrange ABD. They would just go into ABD. So the way that our combinations would work is we're basically taking the permutation, so that 4 choose 3, that permutation of 4 comma 3, and we got 24 of them. We're going to divide that by 3 factorial, and 3 factorial is the number of ways I can rearrange those 3 letters. 3 factorial ends up being 6. There's 6 ways I can rearrange those letters. And so what happens is we have 4 factorial divided by 3 factorial times 3 minus 1 factorial, and we get 4. So the formal definition, or the formal formula now for combinations is this n factorial over r factorial times n minus r factorial. And so that's just going to divide out all the different ways I can rearrange those 3 letters, and then kind of the ones that we didn't pick as well. So hopefully that makes sense. So let's think about this. All right, so we have this. Chatham County Elementary School is choosing a school improvement committee from the 32 teachers that are currently employed. They want to figure out how many possible committees there can be formed if there needs to be 5 teachers on that committee. So if we went back to like our old school way of thinking, let's say order mattered. So if order mattered, we would choose 32 and then times 31 and then 30 and then 29 and 28. That would be a permutation, right? So that would be a permutation of 32, choose 5. But what happens here, so if I were writing out the permutation, that would be 32 factorial divided by 27 factorial. But now what I want to do is I want to divide out the number of ways that these 5 teachers can be rearranged. And those 5 teachers are going to be rearranged by doing it 5 times 4 times 3 times 2 times 1. So 5 factorial. So that's what we're doing. We're basically dividing this by 5 factorial. And so in this case, we're going to multiply this denominator by 5 factorial. And so it's just going to be a combination of 32, choose 5. And so you can put this into your calculator, the 32 factorial divided by 27 factorial times 5 factorial. Or you can just put this combination of 32, choose 5. And if you do that, you should get 201,000 is still a very big number. 376. So that's how many different committees we can choose from the teachers, from those 32 teachers. We're going to assume that all those teachers want to be on that committee. And that's how many different ways we can choose them. But order does not matter in this case. So if it's a committee, so some keywords you see are like committee. So committee is going to mean that it doesn't matter if they picked first or picked last. Whereas before, when we were talking about permutations, they were given specific positions, like they were being picked to be president or vice president or whatever it is in leadership positions. But if it's just a committee, it does not matter what order they're picked in. So that is combinations.